Hello everybody, myself Vishaka Kumre. Today we are going to discuss about use of dimension tolerance, geometrical tolerance and surface finish symbol in machine component drawing. First, dimension tolerance. Dimension tolerance definition. It is defined as the permissible or acceptable variation in dimensions such as height, width, depth, diameter, angles of a part or total amount of which a specific dimension is permitted to vary. It means how much variation we have to permit with a given dimension. We can indicate dimension tolerance in a below diagram. In this diagram, the width of specific part is expressed as a numerical value which is 40 and other is a measuring unit in mm. Next is a dimension tolerance sizes. First, angular size dimension tolerance. It specifies the allowable variation on the size or gap formed by two angular elements of shape. It means variation occur between sizes or gap by two angular elements. Second, curve dimension tolerance. It is a tolerance on dimension for a curve feature element measured along the entire path of curve. It measures the entire path of curve for variation. Diameter dimension tolerance. It is allowable variation of the size of a hole in a feature. Next, radial dimension tolerance. It is allowable variation for the radial distance from the center of feature circular to the curve to a point of the curve. Means variation occur between the radial distance from the center of circular feature to the curve. Fifth, location dimension tolerance. It is allowable variation in locating one feature of a point with respect to another. Means variation occur between 2 points of feature. Next, factor affecting choice of dimension tolerance. These are the diagrams of sizes of dimension tolerance. Next is factor affecting choice of dimension tolerance. First, method of manufacture equals to capability or accuracy of process. It means manufacturing a product, it depends upon the capability and accuracy of a process or dimension tolerance. Second, size of atom. Small things that have smaller tolerance. It means it depends upon the smaller size of product. Third, allowable cost. Smaller tolerance is more expensive. It means small size of product are expensive than the other. Fourth, desired quality equals to higher quality implies a smaller tolerance. Fifth, interference. Fifth, material characteristics is equal to allowable expansion due to the temperature variation. This is happen because due to change in temperature, the characteristics of material changes. Interfaces equal to alignment and fit of a product. 7. Standard equals to specific in variation British standard. Next, application of dimension tolerance. First, general tolerance. It applies to all dimension in drawing, usually shown in title block and usually applies to the non-functional dimension. Second, individual tolerance. This tolerance for a particular dimension only and usually for functional means critical dimension. Below are the diagrams of general and individual tolerance. Next, why it is necessary to use. First, dimension tolerance are key in making parts right. Means without dimension tolerance or dimensioning, we cannot manufacture specific part or product. Using them appropriately will save the time spent, coordinate with the manufacturer circumstances, design issue, and reduces unnecessary cost. It means if we create appropriate or accurate a specific product, it will reduce our design issue, necessary cost, and time. Thank you.
Myself, Srilekha Kharat. Dimension guidelines. The primary guideline is that of clarity, and whenever two guidelines appear to conflict, the method which most clearly communicates the size information shall prevail. First, every dimension must have an associated tolerance. Second, avoid over dimensioning over a part, that is, double dimensioning of a feature is not permitted. Dimensions shall be placed in a view which most clearly describes the feature being dimensioned. Minimum spacing between objects should be maintained. A visible gap shall be placed between the end of extension lines. That is, hidden lines are less clear visible than visible lines. A visible gap shall be placed because between the extension lines and features to which they refer. Manufacturing methods. Manufacturing methods should not be specified as part of dimension. The drawing should define a part without specifying manufacturing methods. Thus, only the diameter of a hole is given without indicating whether it is to be drilled, rimmed, punched, or made by any other operation. That is, each dimension shall have a tolerance except for those dimensions specifically identified as reference, maximum, minimum, or stock. Dimensioning and tolerancing shall be complete so there is full understanding of characteristics of each feature. Nothing should be assumed, or neither scaling or assumption of a distance or size is permitted. Each necessary dimension of an end product shall be shown. The use of reference dimensions on a drawing should be minimized. Don't place dimensions within the boundaries of a view. Dimensions for materials typically manufactured to gauges or code numbers shall be specified by numerical values. Like for example, wire, cables, sheets, rods, and other materials manufactured to gauge or code numbers shall be specified by linear dimensions, which are indicating the diameter or thickness. Gauge or code numbers may be shown in parentheses following the dimension. Unless otherwise specified, angles shown on drawings are assumed to be 90 degrees. A 90-degree angle applies where center lines and lines depicting feature are shown on a 2D drawing. So, and no angle is specified. A basic 90-degree angle applies where center lines of features in a pattern of a surfaces are shown at right angles on a 2D drawing. Dim- uh, Dimensioning to hidden lines should be avoided whenever possible. Depth of blind, counterbore, or countersunk holes may be specified in a note along with the diameter. Diameters, radii, squares, counterbores, spot faces, countersinks, and depth should be specified with symbol. Leader lines for diameters and radii should be radial lines. Dimensions should be arranged to provide required information for optimum readability. It should be used properly and shown in true profile views and refer to visible outlines. A zero basic dimension applies where axes, center planes, or surfaces are shown coincident on a drawing. Now, there are types of dimensioning: millimeter dimensioning, decimal inch dimensioning, decimal points. Decimal dimensioning shall be used on drawings except where certain commercial commodities are identified by standardized nominal size designations such as perm and lumber sizes. First is millimeter dimensioning. First point, where the dimension is less than 1 millimeter, a zero precedes the decimal point. Second, when the dimension is a whole number, neither the zero or decimal point is shown. Third, where the dimension exceeds a whole number by decimal fraction of 1 millimeter, the last digit to the right of the decimal point isn't followed. Neither commas nor spaces shall be used to separate digits into groups in specifying millimeter dimensions on drawings. Next is decimal inch dimension. A zero is not used before decimal point for values less than 1 inch. Zeros are added to the right of decimal point where necessary. A dimension is expressed to the same number of decimal places. Next is decimal points. Decimal points must be uniform, dense, and large enough to clearly visible and meet production requirements. Decimal points are placed in line with the bottom of the associated digits. This was all about dimension guidelines. Thank you.
Hello friends, I am Aishwarya and I am representing geometric dimensioning and tolerancing. Geometric dimensioning and tolerancing is an international language used on drawing to accurately describe a part. Geometric dimensioning and tolerancing is a language used on mechanical engineering drawing composed of symbols that are used to efficiently and accurately communicate geometry requirements for associated features on component and assembly. GD&T is a design tool. GD&T communicates design requirement. It consists of many symbols. Uh, Whether it is a part, and we represent a dimension using the symbol. Tolerance, allowance for a specific variation in the size and geometry of part. It is the variation, positive or negative, by which a size is permitted depart from the design size. Tolerance is given to any product to vary the dimensions within this limit. There are two types of tolerance. One is the bilateral tolerance and second one is the unilateral tolerance. Unilateral tolerance is allow vary only above or only below the basic line. Bilateral tolerance is allowed to vary both the above the zero line or below the zero line. There are five categories of symbol. First one is the form. Form control straightness, flatness, circularity and cylindricity. Second one is the profile. Profile controls line of profile and line of and surface of profile. Orientation. Orientation controls angularity, perpendicularity and parallelism. Location controls position, concentricity, and symmetricity. Fifth one is the runout. Runout controls total runout and runout. Datum. Datum is a theoretically exact point, axis, or plane from which the location or geometric characteristics of a part features are established. It is a starting point or origin of any diagram or any component. Datum feature is usually an important surface where all other dimensions need to be specified with reference to it. Datum features are selected to meet design requirements. Whenever we design any component, we want to first fix the datum. Symbols used in geometric dimensioning and tolerancing. First one is the flatness. It is a common symbol that references how flat a surface regardless of any other datum features. It comes in useful if a feature is to be defined on a drawing that needs to be uniformly flat without tightening any other dimensions on the drawing. Uh, Flatness tolerance is always less than the dimensional tolerance associated with it. In short, flatness is the condition of a surface having all elements in one plane. Second one is the straightness. Straightness actually has two very different functions depending on how it is called out. First one is the surface straightness and second one is the axis straightness. Surface straightness is also called as a normal form of straightness. It is a tolerance that controls the form of line somewhere on the surface or feature. Second one is the axis straightness. Axis straightness is a tolerance that controls how much curve is allowed in the part's axis. Circularity. Circularity symbol is used to describe how close an object should be to a true volume. A true circle, it is a two-dimensional tolerance. It describes the condition of a surface of revolution like the cylinder, cone, sphere, where all the points on the surface intersected by a one plane. Sometimes it is also called as roundness. It controls the overall form of a circle, ensuring that it is not too oblong, square, or out of round. It is independent of datum feature. Next one is the cylindricity. Cylindricity symbol is used to describe how close an object conforms to a true cylinder. It describes a condition of surface of revolution in which all points of a surface are equidistant from a common axis. Cylindricity is a three-dimensional tolerance that controls the overall form of cylindrical feature to ensure that it is round enough and straight enough along its axis. Cylindricity is also independent of datum feature. Symmetry. Symmetry is a three-dimensional tolerance that is used to ensure that two features on a part are uniform across a datum. Symmetry is not very commonly used in GD&T because it is very limited functional usage and the verification and measurement of symmetry can be difficult. In short, it is a condition in which is a symmetrically disposed about the center planes of a datum line. Next one is the concentricity is a tolerance that controls the central axis of the reference feature to a datum axis. Sometimes concentricity is also known as coaxially. It is describes the condition in which two or more features in any combination have a common axis. Concentricity is a very complex feature. Next one is the position. Position controls the location and orientation of a feature in relation to its datum reference frame. It defines a zone within which the axis of center plane of a feature is preferred to vary from true, that is theoretically exact position. Next one is the perpendicularity. Perpendicularity is the condition of a surface, axis or line which is 90 degrees from the datum plane or axis. Perpendicularity has two different functions on which how it is called out. First one is the surface perpendicularity. Surface perpendicularity is a tolerance that controls perpendicularity between two 90-degree surfaces. Surface perpendicularity is controlled with two parallel planes acting as its tolerance zone. Axis perpendicularity is a tolerance that controls axis perpendicular to a specific axis needs to be a datum. Next one is the angularity. Angularity is a symbol that describes the specification orientation of one feature to another at reference angle. It is the condition of a surface, axis or center plane which is at a specified angle from a datum plane or axis. It is a generally 2-dimensional line reference to another 2D element, but more commonly it relates to the orientation of one surface plane relative to another datum plane in 3-dimensional zone. This tolerance indirectly controls the angle by controlling where the surface can lie based on the datum. Next one is the parallelism. Parallelism is the condition of surface, axis or line which is equidistant at all points from a datum line or axis. Perpendicularity actually has two different functions. First one is the surface parallelism and next one is the axis parallelism. The surface parallelism is a tolerance that controls parallelism between two surfaces. The surface form is control similar to flatness with two parallel planes acting as its tolerance zone. Next one is the axis parallelism is a tolerance that controls how parallel a specific part central axis needs to be to a datum plane or axis. Parallelism is mostly called out as surface parallelism. Next one is the profile of a line. Profile of a line describes a tolerance zone around any line in any feature, usually of a curved shape. Profile of a line is generally two-dimensional tolerance that can be applied to any linear tolerance. It is the condition permitting a uniform amount of profile variation either unilaterally or bilaterally along a line element of a feature. It is called out on a surface like a radius on a part. Profile of a line would vary, specify how much that cross section would vary from a true curve radius. Second one is the profile of a surface. Profile of a surface describe a three-dimensional tolerance zone around a surface usually which is advanced curve or shape. It is the condition permitting a uniform amount of profile variation either unilaterally or bilaterally on a surface. When surface profile is required, there are no tolerance on the dimensions that describes the surface. Next one is the runout. Runout is how much one given reference feature or features vary with respect to another datum when the part is rotated 360 degrees around the datum axis. It is essentially a control of circular feature and how much variation it has with the rotational axis. Next one is the total runout. Total runout is how much one entire feature or surface varies with respect to datum when the part is rotated 360 degrees around the datum axis. It is a combination of radial variation as well as axial variation. Next one is the least material condition. Least material condition is a feature of size symbol that describes a dimensional or size condition where the least amount of material exists within its dimensional tolerance. For example, largest hole size or smallest shaft size. Next is the maximum material condition is a feature of size symbol that describes the condition of a feature or part where the maximum amount of material exists within its dimensional tolerance. For example, minimum hole size and maximum shaft size. Feature control frame. In geometric dimensioning and tolerancing, a feature control frame is required to describe the conditions and tolerances of a geometric control on a part's feature. The feature control frame consists of four pieces of information. First one is the GD&T symbol or control symbol. Next one is the tolerance zone type and dimensions. Third one is the tolerance zone modifiers, for example, feature of size, projection, etc. And fourth one is the datum reference. In figure, the leader arrow indicates that the feature of the geometric control is placed on. If the arrow points to a surface, then the surface is controlled by GD&T. If if a arrow points to a diametric dimension, then the axis is controlled by geometric dimensioning and tolerancing. Second one is the geometric symbol. This is where your geometric control is specified. Third one is the diameter symbol. If the geometric control is a diametric tolerance, then the diameter symbol will be front of tolerance value. Suppose we have to control the radii, then we use the symbol of radii. Fourth one is the tolerance value. If tolerance is a diameter, you will see the phi symbol and next the dimension signifying a diametric tolerance zone. The diameter is allowed to vary only between 0.03. Fifth one is the modifiers. We use different modifiers, for example, least material condition, maximum material condition, etc. So we use this symbol. Sixth one indicates A. It is a primary datum. In a reference to it, we design a part. Second one is the secondary datum. It is always placed on right of the primary datum. It indicates a secondary datum. And eighth one that indicates C is a tertiary datum that always placed on right of secondary datum. Thank you. And next one is the advantages. First one is the standardized and international system. In the whole world, this system is accepted. So we going to other country. We can't explain, we directly use symbol. There is no need to explain a single line. Next one is the provides a clear and conscious technique for defining a reference coordinate system on a component or assembly. Third one is the reduce the need for drawing notes to describe a complex geometry requirement on a component. More flexibility, particularly for complex shape. Whenever we design a complex shape, we use directly this symbol, so the need of nodes is reduced. Thank you.
Hello guys, myself Shivani Wakode. I am representing the applications of surface finish symbol. Before we get on with the surface finish symbols and their applications, let's understand how surface finish is defined. First point is that definition of surface finish, and second point symbols, and the third point use of surface finish symbols. Next, Surface finish is the measure of overall textures of a surface that is characterized by the lay, surface roughness, waviness of the surface. Surface finish, when it is intended to include all the three characteristics, is often called surface texture to avoid confusions. Surface textures it consists of surface finish, waviness of the surface, and lay and surface roughness. And the next point is that lay. The lay is the direction of the predominant surface pattern, and it's usually determined by the productions method. Lay means the predominant and surface uniform surface irregularity which is produced due to the feed more of the tool on the surface. There are different types of lays: horizontal lay, vertical lay, and cross hatch isotropic. We already study about the different types of operation in basic mechanical. So मैं orally बताऊंगी किस ऑपरेशन में किस टाइप के लिए यूज होते हैं. फर्स्ट planning and passing operation, circular lay is used, and honing, knurling, in operation honing, knurling, cross lay is used. In grinding and lapping operation, multi-directional lay is used. And next point is that surface roughness. Surface roughness is a measure of finely spaced surface. Next point is that waviness. Perfection, but there may also be such coarse irregularity. Waviness is a large wavelength irregularity which have much greater spacing as compared to the roughness. In waviness height, if the width is more, then the surface will be said to be relatively more smooth. The next point is that surface finish symbols. In a United States, surface finish is usually specified using ASME standard. The rest of the world common uses Internal Organization for Standardization IS 130. Next point is that surface symbols. Symbols indicate the base wall consists of two layers of unequal length that 60 to the line represent the surface. And the second symbols is indicate if removal of by machine it is added symbol. If you remove materials, this symbols indicate if removal of material is not emitted in the sides added to the circles is added symbols. If you want to remove material, the circles is in between two unequal things, and the wall is in this in program A is get center average value, get production method, C in the engineering allowance according and 2000. First symbol is indicate the basic symbol consists of two legs of unequal lengths included at 60 degree to the line representing the surface. Second symbol is indicate if removal of material by machine permitted, a bar is added to the symbols. And the third symbol is indicate if removal of material is not permitted, then the circle is added to the symbols. And the fourth symbols, in that fourth symbols, A is indicate center line average value, B is indicate producing method, and C is indicate sampling length, and E is indicate machining allowance. Uh, according to examination, this diagram is most important. And the next point is that applications of symbols. To in engineering drawing, we need to convey information about some of the manufacturing process that are to be used and required results from the process. Two examples of this are surface finish symbols and the welding symbol. Information of the sets of the symbol will tell the productions and manufacturing some things about the process that live to be used in order to produce the finished item. This information helps them plan the process of the sequence and find consequently also the flow of material through the productions plant. Thank you.
Myself, Komal Ranmale. I'm representing the point surface finish. Basically, surface finish, we know that surface texture or surface topography. Surface finish is a measure of the overall texture of a surface that is characterized by the mainly in three parts, which is lay, roughness, and waviness of the surface. This is the diagram of relationship between waviness, lay, and roughness. In that diagram, we clearly see the what is meant by lay, roughness, and waviness. Step by step, we understand the in details. Surface roughness is a measure of fine space surface irregularities, and waviness can be defined as surface roughness speaks to fine different imperfections, but there may also be much coarser irregularities. For example, surface may be wrapped or deflected from the ideal. Next point is measuring and inspecting the surface finish. There are number of different characteristics measure of, but two are most important characteristics are one is RA and second one is D. RA means height of the roughness peak and second one is their separation. There is three method from which we surface finish is we can measure. One is profiling technique, second one is area techniques, and third one is microscopic technique. In this symbol, we see the various symbols which representing the in machining manufacturing the any product. In first symbol there is two legs, one is small and another is large leg, and in between there is 60-degree angle. And in first symbol we can use product can be manufactured by any method such as casting, forging, etc. And in second one symbol there is one triangle is completed in between those small and large leg, means material is removed from in machining process. And third one is there is circle in between two legs, which means products we have to manufacture but material removal is prohibited. There is various symbols in lays. First one is parallel lay, uh, parallel lay, which is we see in shaper machine. Second one is perpendicular lay. Third one is circular lay. Circular ray, we see these symbols in facing operation. R means radial lay and X means angular lay in both direction. In the diagram, we see the various symbol which represent the there are various meaning of each symbol. First one is two legs, which means basic surface texture symbol. Second was is represented by B, means material removal is required in machining. Whenever we machining, the material is must be removed in that type. We use this type of symbol. Third one is indicate a minimum amount that must be removed. This one is indicated by C. And D is material removal is prohibited, which is shown in figure by circular arrow in between two legs. And E means horizontal bar to help locate parameters and value, which indicate the under root. There are many surface grade numbers are shown by various symbols. In BIS system, Bureau of Indian Standard, numbers are not recommended. In that case, we use the grade. There is 52 0.025 to grades, which is in micrometer and which is represented by various symbols, also roughness grade number or finish marks also. Means 50 is represented by N12, or there is symbols which is reverse triangle we use. When one reverse triangle means higher rough, roughness, and when there is four triangle at the ends means lower roughness. Thank you guys.